Today we're going to be going over some statistic type questions. Although we have done things like cumulative frequency, we haven't really focused very much on the basics of statistics. So we're going to be focusing on that in sort of exam style questions. So this is the first question we're going to be going over. Find the median number of calls. Well, you should know that for the median, the first thing you need to do is reorder the numbers. This is what we have done here. And then we need to find the exact middle of these numbers. Now, because there's an even number of numbers here, it becomes more challenging. And the reason why is because there's going to be two central numbers. And we know there's an even number of numbers because when we count them, there's 8 numbers altogether. Now there's specific formulas you can use to find the median. You can either cross them off one by one, and then you'll find that both the 4 and the 5, or the 4th and the 5th number, are in the middle of this set. So we need to pick a number which is halfway in between 4 and 5. This is clearly going to be 4.5. Now this is an easy way of doing this. But another way of doing it, if you couldn't work out the number halfway in between 4 and 5, all you would need to do would be to add them together and divide them by 2. And the reason why this is significant is because we're finding the average of 4 and 5. And then continuing with this problem, now we're going to find the mode and the upper quartile. Now the mode and the upper quartile can be considered quite easy, similar to the median. So the median is always the middle number in between two things. You should know that from M5. The mode is the most occurrent number. And then it's the upper quartile, which is a little bit more challenging. So let's see how we're going to do that. So the mode is the number that appears the most. And if we have a look at this list up here, we can see that the most frequent number that occurs is the number 4. So we will write that down as our answer. In addition to this, we want to find the upper quartile. Now let's imagine we've got a set of data such as box plot data that we organise into a box plot, or we've got data that we organise into cumulative frequency. This is exactly the same thing. Remember, the upper quartile represents 3/4 of the data. So what we're going to do is we're going to focus on both the left-hand side of the median and the right-hand side. And the left-hand side will obviously include the first quartile of data, which is where Q1 will occur. And then the right have 8 numbers, and you had a long list of data like this. This would be the easiest way to do it. You're going to look at how many numbers you've got, find the median, and then you're going to split both sides in half. So on the Q3 side, we're going to split these numbers into 2 sections. And this split will represent exactly halfway in between 6 and 7, and we can know that that's 6.5, or an alternative way of doing that would be to add them together and to divide them by 2, and then that will give us the quartile number 3. If you wanted to do the same for quartile 1, all you would do here would be to split this data into half, and then we could see that halfway in between the median and the beginning number is going to be between 3 and 4. So the middle number, or quartile 1 of this set of data would be 3.5. Then finally, we're going to answer the last question, which is combining stats and probability. So let's see what this question is about. This question here is about the probability that managers receive no more than 5 calls in a randomly chosen hour. Now this is easier than it actually looks. So no more than 5 calls. So you look at the data and you are going to count. So we're going to include all of these numbers here. And this is a bit of a fancy way of writing it, but it's quite straightforward. What's the probability that the phone calls are either 5 or less? And that's what no more than 5 are. So we're going to look about how many numbers there are altogether, and it's clear there are 8 numbers, and that's going to be significant because that's going to be the denominator of our fraction, because we're asking out of how many numbers altogether is it going to be 5 or less? Well, it's going to be 5 numbers out of 8. So that's simply going to be our answer. So you just write it like this. And if you wanted to write it as a decimal, you would type this into the calculator and you would get the following answer. If you didn't want to do it so complicatedly using your calculator, you would just write 5 divided by 8. The question is going to be a little bit more quicker to go over because it's quite straightforward. Now, you should always read the question, but often the questions in your exam, they are significant, but you really need to look at the key bit of information. And if it's got a graph, you often don't really need to read the question in that much detail because it's normally quite obvious what you're supposed to do. The column below shows the number of wet days per week recorded for a period of time in Melbourne, Australia. So for me, that's a really straightforward question, so I don't really need to look at it anymore. So question A, write down how many weeks are recorded altogether. So we're going to say, well, how many days are recorded altogether? Well, we look at the bar chart and that will help us. So let's do that. Number of wet days per week, number of weeks. So this is the first question where you've just got to think a little bit more than normal. So in number of wet days per week, we're going to say that there were 0 wet days in 4 of the weeks. There were 1 wet day in 1 of the week. There was 2 wet days in 3 of the weeks. So all you need to do is find the frequency value of each of the bars, and most questions to do with frequency will require you to find the frequency of each of the bars for a bar chart, and then you just add them all together. So all we're going to do is 4 plus 1 plus 3 plus 2 plus 1. That's all you need to do. 4 plus 1 plus 3 plus 2 plus 1 is 11. Question B. Now I'd like you to pause this video right now and have a think about what the word modal will link to, bearing in mind we just did this in the previous question. Now you've hopefully paused the video, hopefully you remembered that the word modal looks very much like the word mode. Therefore, what we need to do is see which bar is most common. And you can see clearly that the bar that's most common is going to be 0 days because this has got the biggest bar. So we're going to say that for 0 wet days, as you can see on the picture, there are 4 weeks. For 1 wet day, there is going to be 1 number of week. For 2 wet days, there's going to be 3 number of weeks, and so on. So let's see what my table should look like. But what's the most important thing is, if you want to find the mean of anything, whether you're using a graph or a table, you don't need to create this into a table, but I think this is the easiest way to explain it, is that you need to find the total number of days altogether in this problem. So we're going to say that the 0 amount of days is insignificant in terms of calculating the mean. Can you pause the video and think why? Hopefully you worked out that it's insignificant because 0 times 4 is going to give us 0, and therefore contribute to our total number of wet days. But we can see that on 1 wet day, this happened in 1 week. So for this option here, there is a total of 1 wet day. Whereas for the next bar, it changes slightly and it should start making a little bit more sense. For this bar, there are 2 wet days and this happens 3 times. Therefore, this bar gives a total of 6 days. And if we continue the pattern by multiplying across these numbers, we get the following total. 1, 6, 6, 5 and 5. Now, there's an error in my workings out here. Can you pause the video and work out what my error is? Fantastic. Hopefully you noticed that this was the error. This should be 4 times 0 equals 0. So again, this is insignificant because there were no weeks where there were 4 wet days. So if we add together the actual numbers, we get 18 altogether. And you can do this in another way other than a table, and I can show you here. In this particular video, we can see that the person has done this by putting them as brackets on top of a fraction, as the numerator is a fraction, and the denominator is 11, and the reason why is because there are 11 weeks total. So we're going to say how many days there are altogether out of a total of 11 weeks. So this will work out the average number of wet days per 1 week, and we can see that our answer is simply going to be 18 over 11, which when simplified or written differently as a decimal, that becomes 1.64. And what we actually mean by this in a sentence is that on average for every week, there's going to be 1.64 wet days. Now let's finally move on to question D. So if we have a look at question D this time, we will find the following. It's asking us to determine the percentage of weeks which had more than 2 wet days. So we need to look carefully at our graph. So we know that altogether that there are 11 wet days, but we need to see out of the 11 weeks, how many of those weeks have more than 2 wet days. So we need to focus on this bar and this bar. So let's see what would be the most beneficial thing to write down. So like I said, we'll focus on these 2 bars specifically because there's no other data in the other bars. And we're going to find out specifically how many weeks are in bar 3, as in how many weeks occur when there are 3 wet days. So there are 2 weeks when there are 3 wet days. And then there's also going to be 1 week where there's 5 wet days. So the percentage of the weeks is going to be to do with a fraction which we're going to generate now. The numerator is be 3 and the denominator is going to be all of the weeks altogether, which is 11. And then if we rewrite this as a fraction, we're going to get 3 out of 11. Now, if you write this as a decimal, we're going to get the decimal 0.2727. And if we need to convert something from a decimal to percentage, what do you think we do? Pause the video and think. Hopefully, you noticed that we have to multiply by 100 to get from a decimal to a percentage. So our answer is going to be 27.3%. And the reason why we change this to 3% is because it's rounded to 1 decimal place.